Module 3 review. All right, here's a nice word problem for us. Suppose you have a $195 gift card for video games. You spend on average $22 per week for games. Write a function to evaluate this, to model this situation where W is the number of weeks and G of W is the value in dollars remaining on the card. Then after we get that together, then we'll evaluate G of 4. So I'm gonna do this in the form of y equals mx plus b, where m is the slope and b is the y-intercept. Now in context type problems like these ones with words, m, the slope, is the rate of change. How much is it changing? And then b is the starting value. So I can see that the gift card is going to start at $195. That's positive. That's because you get that. But then it says the average rate of change here, and it didn't say rate of change, but it's $22 per week. So it's not just 22 though, because it's being spent, which indicates that it's going to be losing $22 every week. If I multiply this by the number of weeks, so I'll use W, then I would get the Y value, which we'll just show in function notation as G of X. So this is what I get as my model, the function to model this situation. And yeah, sometimes I think I've seen this, and I believe that Canvas will accept this. Some students prefer to write, say, you're going to start with the 195, and then you're going to take away $22 every week, so 22 times W. Either one of these work. You don't have to put both, just one or the other will work, okay? But then it says evaluate G of 4. I'm going to use the regular slope-intercept form for me. Of course, you're not required to do that, but that's what I'm going to do. So I'm going to set it up. And at this point, of course, I guess I put an X there. Sorry, it should be W. But either way, we're going to replace that with a 4 anyway. So there's a 4. So after 4 weeks, and that's what this would interpret as, how much money would be left on the card after 4 weeks. Well, that means we're looking at G of 4. And I'm just going to put this in the calculator just really to save some, not just some time, but some space. But negative 22 times 4 plus 195 in my calculator shows that the final amount would be $107. Okay. So G of 4 equals 107. You could say $107 left on the card after 4 weeks. And that's how this would interpret, by the way, if by chance you had written it as an ordered pair as 4107 like this. Okay. The 4 indicates how many weeks have passed. The 107 tells you how much money is left on the card. So there you go. All right, for this problem, they've given us the function right here, but it says a study at a certain restaurant found a linear relationship between outdoor temperature and average number of cups of hot chocolate sold. The relationship can be approximated by the following linear model, where X is the outdoor temperature in Fahrenheit and C of X is the number of cups sold. So C for cups, X for Fahrenheit, I guess, but C of X equals negative 1.22X plus 106. What does the slope represent in this context? Well, just let's start with what the slope is. So the slope is showing it's always the coefficient of X. It's negative 1.22, okay? But what would it represent? Say it's a slope, and remember, if we see slope, we need to know that that also means rate of change. And the reason why that's important is because a rate indicates that you're comparing two quantities. So it's negative 1.2 to something per something else. And even sometimes with that per word, that indicates there's some fraction line, division, something like this, okay? So like miles per hour, okay? Now, in this case, it's negative 1.22. And remember, the two things that we're comparing on this, and it did talk about this up here, looking at number of cups of hot chocolate sold with relationship to temperature, okay? Which is showing in Fahrenheit, and that's okay. Now, for context right here, it does say C of X. Okay, now remember, that would also tell us up here in the function that C of X, that's cups sold. But C of X also represents Y. So this is just, again, there's a little bit more to it than this, but for now it's just important to know that the C of X is your Y. And Y's are always in the numerator, right? Y's represent rise. And the reason why that's important, because when we label this, that's our numerator in this kind of fraction looking thing. So it's negative 1.22 cups, and then of course the other label there would be degrees Fahrenheit. Okay, so in a perhaps more clear interpretation of this would be that the store will sell a 1.22 cups less for every increase in temperature of 1 degree. I think I could have said that better. I'm sure you could, but however you say it, it needs to resemble something to that effect, okay? And why is it 1.22 cups less? It's because it's negative. Some people say that they would, I don't know, not sell 1.22 cups, or they would lose 1.22 cups for every degree sold, something like that, okay? Then the final point here, use the model to predict the number of average number of cups of hot chocolate sold where the temperature outside is 35.9 degrees Fahrenheit, which is the X value, right? X is the outdoor temperature in Fahrenheit. So what I'm going to do is I'm going to go back. I'm going to take that original function, c of x, which equals negative 1.22x plus 106. And right here it tells us that we want to see how many cups sold for 35.9 degrees. So I'm going to go into this function. That's an x value, okay? So I'm going to replace my x's with 35.9 degrees. And then after that, it's all calculator work. So 35.9 here and 35.9 here. So that would be C of, well, 35.9, which would equal, I'm just going to plug this into the calculator. You could do it piecewise if you'd like, but not only for the sake of time, but just because it's easier. 1.22 times 35.9 plus 106. Enter. I get 62.202. It did say to round our answer to the nearest whole, so rounded how many cups for 35.9 degrees Fahrenheit. It appears that we would expect to sell 62 cups. And again, I'm labeling this because it's a word problem, but the interpretation is there. If the temperature outside is 35.9 degrees Fahrenheit, you would expect to sell 62 cups of hot chocolate. All right, so it wants the equation of a line that's parallel to this one, but it has to go through this specific 0.45, all right? So the main thing we need to remember about parallel lines is that they have the same slope, okay? So if we can just look at the equation that's given and find its slope, the equation of the line parallel to it will have the exact same slope. And I think we did cover that last time I was here, was that 3.5-ish? And we also talked about perpendicular slopes. I know this one's not asking for perpendicularity, if that's a word. But remember, for perpendicularness, you're looking at, it's got to be the opposite, and then it's got to be its reciprocal. You got to flip it too, okay? This one, though, same slope, no problem. So I'm gonna manipulate this equation to find its slope. Just changing it into slope-intercept form, okay? So I'd say first off, let's go ahead and subtract 5x from both sides. Now I'm putting it right underneath that -8, even though I know those are not like terms to combine. I'll drop my negative y here, which now equals, to keep this in slope-intercept form, I want my x term first and then the number second. Last thing here, I treat this as a phantom -1 and divide all the terms by -1. For those of you that know better, you could just say, you're going to change all the signs, and that would be fine too, okay? So this then makes slope-intercept form. Y equals, now it's 5x. And then really the y-intercept isn't going to make a difference for us, plus 8, okay? But the main thing here is that we see that the slope is 5. So in our new equation, where y equals mx plus b, I just found the slope is 5. All we need now is to find its corresponding y-intercept value. Now you got two different methods. You can use slope-intercept form, or you can change it into point-slope form and then use that to simplify that into slope-intercept form, but the choice is really yours. All right, point-slope form it is, which means that, well, we'll just fill in that y-intercept as we go. So remember, it's y equals mx minus x plus the y value. And again, we just found the slope. It should be the same slope of 5. And we do have this ordered pair right here, x and y values, to replace. Remember, it's x minus x, and you see the x is 4, and the y value is 5. So replace that y with 5. And then once we distribute and combine like terms, we will have our simplified equation on this. So I'll go ahead and distribute the 5 here, so that'd be 5x. All right, so, and then we still got the plus 5 there, of course. So, yeah, just final simplification here. Combine these two. Negative 20 plus 5 is negative 15. And so our final formula, or slope-intercept form, y equals 5x, which we already knew. It's just now we see that the y-intercept here is 0, negative 15. And this would be our equation. So given these 2 points, 12, 3, and 0, 7 on the line, find its equation in the form y equals mx plus b. Now I'm going to skip something, even though some of you may see a shortcut on this one. I'm purposely skipping it so that we can kind of look at compare the two strategies, all right? So the first thing we would need to do on this one is to find the slope. Okay, so here's my slope formula. Here I'm going to say this is x1, y1, so the x is in the denominator, y is in the numerator. And then the second point, x, I guess that's fine. x2, y2. Sorry, it's kind of sloppy there, but x in the denominator is 0, and the y in the numerator is 7. So if I put this into the calculator, negative 4 over 12, and negative 1/3.
12, which is negative 1/3. Yep.
So that is our slope right there. Okay, and again, you could pretty much plug that into the slope-intercept form for you. Now, I said I'd do the second method, which we've already seen. Remember, it's y equals mx plus b, and we just found the m to be negative 1/3. What we need then is the b value, right? So, again, I'll just go back and use the original x and y values there, x1 and y1, where x is 12, and then the y value is 3. And then we're just solving this equation for the b value. Now, I'll give you a little bit of a shortcut here at the end, but let's go ahead and solve this, okay? So negative 1/3 times 12 would be negative 4. So then I got 3 equals 4, but then plus b right there. Sorry, that's kind of a sloppy b. That's a little bit better. Yeah, so at this point now, I have to add 4 to both sides.
Negative 1.
And 3 plus 4 would be 7 on that. So that's our b value on that. Yeah, no worries. So now that we have the m, which is the slope, and the y-intercept, the b value, yeah, let's just go and write this out. Y equals mx plus b. The m is already negative 1/3, and we just found the b to be a positive 7, so we just put that in as plus 7. This is the slope-intercept form of the line, okay? Now, as promised, I told you there's kind of a quick way to find the y-intercept, and it comes from manipulating y equals mx plus b, right? So if you ever wanted to solve for the b, going back to 1.10, you'd just subtract mx from both sides. Now, y is not a like term with mx, so it just would read as y minus mx, and this would equal the b value, okay? And you can see that this would work, right? You'd replace the m here with negative 1/3, and then the x value, we already know we had 12. You could use the 0, 7, by the way, but I purposely used 12, 3, and then the y value is the 3 there. If you solve this, you're going to get the same answer of 7 right there. And again, you can plug that directly into the calculator. B still will be 7 here, okay? Now, I said some of you may have noticed something earlier, and that's the y-intercept. It was given right there. Okay, so sometimes we kind of get a little bit robotic with our calculations. And it's like, yeah, I got to go through the slope formula, then I got to find the y-intercept. But again, just please try not to be that robotic, because if you had noticed that in the beginning, you would have saved yourself all this work. Although I hope the explanation is kind of useful there. Oh. You'll get the same answer. You get the same answer either way, but again, if you can notice that, you'll save yourself some time. And we really want you to to be able to think. I'd say that's outside the box, but I really hope it's not really considered that far outside the box, you know. All right, so this one's very similar to remember the slope is the same for a parallel line. They've already given us a slope in this one. All we got to do is find the corresponding y-intercept. Now this one, of course, is not the y-intercept because the x value is not 0. So we got two different methods. We can use slope-intercept form or point-slope form. Point-slope form it is. Y equals m, and then x minus x. I'll put these in there, x minus x, and then plus the y there. Now, I put the plus y in green, by the way, because if it were negative, then I'd show that as a minus, okay? But right off the bat, they gave us a slope at negative 12, so I'll replace the m slope with negative 12, okay? And then, of course, we do have the two x and y values. There's x and y. And so the x is -4, so let's go and replace that with -4. And then the y value is -35 there, so let's replace that with -35. And you'll see that the minus negative there in black and green, I'm just gonna change that into a plus, so we don't have to worry about minus negative stuff as we start our calculations, especially with this distribution. So that's -12 groups of x, which would be -12 x's. And then -12 groups of +4 would be -48. So we still got the -35 there, because we didn't have any distribution at that point. And you see, it's always two steps with point slope form if you keep it in this format. Distribute, combine like terms, and you're done. So I can see that it's gonna be -12x, that's fine, but I gotta combine these two, and that looks like it's gonna be -83 on that one. So this would be the equation. They already gave us a slope, that was nice. If they gave us another point there, of course, we would have to find the slope ourselves like we did on that last problem, but this one's pretty good. Now, just so we know, you would have gotten the -83 even if you'd used slope-intercept form as well. Here we go, this goes back to 3.6, graphing inequalities like this. So remember, this is already in slope-intercept form, that's pretty nice, which means that it would be kind of like a +0 right here, okay? Which is, the reason why we need that is because we need the y-intercept to do this graph, okay? So there's, the y-intercept would be 0, 0. The x value is always 0 for your y-intercept, but this one just happens to be a 0 y value as well, which puts us right at the origin. I'm going to put that ordered pair right on the graph there, okay? And then the slope is the coefficient of x, and that's 4/5. Both of these are positive, which means that it would be up 4, because that's the positive direction for rise, and then it would be to the right 5, because that's the positive direction for the run. Not the runs, but that'd be up 4 and to the right 5 from the origin, the y-intercept that we put on there. So I go, sorry, that's kind of off, but it's up 4. And then to the right 5, that would be this point right here. I'll write that in though, that's to the right 5. So if we ever don't see anything added or subtracted, that +0 is always there. It's actually there for any value. So yeah, and that's the nice thing about phantom zeros. Sometimes they're useful. I mean, they're mostly not useful, but in situations like this, it allows us to put something there so we can actually visually see it. That +0 was always there, lurking in the shadows, watching, which again is why phantom values are so creepy. But there you go. So this gives us 2 points, and I can actually copy that stair step, right, going backwards. So I'd say left 5 and then down 4, and this would be the other point that I could fit on this graph. Now, in order to make this line, because because we do need to make a line here, we'd say, hey, look, go ahead and just connect these points, right? The problem is this is an inequality, so we have to be careful with what kind of line we use.
Oh, yeah.
So this one is just greater than, which means that this would be a dashed line. I don't know, I'm going to use a dotted line. And, well, it's not going to be perfect, but I'm going to be satisfied with it. You can put some arrows on the end to make it real pretty, like this. Okay, so that's the type of line we need for this problem. It's dashed because it's just greater than. If it was just less than, it'd be dashed as well. It's only when it's equal to that we get a solid line. The dashed line or dotted line like this one indicates that the values on this, the ordered pairs on this line, would make this original statement false because it would be the equality portion of that, okay? Now, however it was taught by the sub, I would say at this point, the next thing we need to do is find a value to test. Now, if you watch the videos, we usually test the origin. The problem is the origin falls on the line right there. So we can't actually use the origin. I just want to use as many 0 values as I can. So I'm actually going to use the ordered pair 1, 0. And I'm testing this in the original inequality. So I go to my inequality, y is greater than 4/5 x. But right there, I'm going to replace the x with 1, because that's the value I'm testing, which, by the way, is right here. That's important to know. And then the y value is 0. And then I'm just checking this for truthfulness. So let's go ahead and put a question mark above that inequality, because I don't know if this is true or not. So I'd say 4/5 times 1. That'd be 4/5. See, that's why it's nice to just work with zeros and ones on this. And so the question then becomes, is 0 greater than 4/5? That is false, The answer to that is no. And since this point is false, that means that everything on this right side of the line, I'm going to call it the right side, would be false. So if you tried 4, -3, that would be false. If you tried -2, -3, that would be false. If you tried 4, 2, that would be false, okay? All those points would be false, so that means I need to shade the other side of the line, which, I guess I'll use blue. Everything on this other side of the line would be true. Now, that means also if you had tested the point, let's say -3, 4 here, and put it into this inequality, you would have found that it gave you a true statement, okay? So you only shade the side of the line that gives you true statements from the value that you test. Some people would say, I don't know, they've said, well, if it points to the right, then you shade up or to the right. I don't know that it really worked on this one, but whatever. Here's this one. Now, of course, there's different ways to do this. Some people would say, I'm going to make a table for the equality portion of this and then graph it that way, and that'd be fine if you did. However, I'm going to use slope-intercept form, so I'm going to change this 8x plus 4y is, I'm just going to do the equal to because I don't really care about the inequality portion of this, okay? I'm just looking for the line that would be created from this equality. So that means I'd have to subtract 8x from both sides. You have to do it this way? No, like I said, you can use a table or just use the x and y intercepts if you'd like. So that becomes then 4y equals, keeping this in slope-intercept form, -8x, and then plus 36. Oh, I guess we'll see a problem with this. See, now when I divide by 4, I do have the slope, but the problem is that my y-intercept is not going to fit on the graph. See, that's plus 9. All right, for this problem, now that we have the actual equation for this, and it is an equation, that's why we're putting a line down on the graph. I don't really care that it's less than or equal to right now, but I can put this on the graph, right? So just from the equation, I know that my y-intercept is 0, 9, because of the plus 9 right there, 0, 9. And then my slope, and this is important too, it's showing as -2. I'm going to show it as -2 over 1. And that way I know to go down 2 and then to the right 1 from that ordered pair. So I'm going to put 0, 9 on the graph. Oh, it doesn't fit, right? So that means I got to go back to the original equation here. Again, I'm not treating it like an inequality yet. I just want to treat it like an equation. And I'm going to have to replace the y here with 0. Let's, well, actually, I'm not going to do that because if I do that, I'm going to get a fractional value, which I don't really want on this, okay? So I'm not going to use y as 0 on this. I'm going to say, you know, if I wanted the values to match, that's, Here's what I'm going to do. I'm going to try y as 1. Let's see what happens on that. So, and sometimes there is a little bit of a need for some guess and test on this, especially when the y-intercept does not fit on the graph. Now, some of you may have gone up here and then said, well, I'm going to go down 2 to the right 1 and then continue that pattern. But I'm going to pretend like we didn't know that, okay? So I'm going to go with 8x plus 4y equals 36. But now I'm going to test the y value that's 1. Okay, and I'll show why this should work here in a second. If I'm wrong, that's fine, because, again, it may take some guess and test. Again, if you tried y as 0 here, you're going to get a fractional value for x, which we don't want. So I'm going to replace the y value with 1. Let's see what happens here. Okay, so 4 times 1 is 4. Now I got 8x plus 4 equals 36. I'm just solving for its corresponding x value. So now subtract 4 from both sides. See, that's 32. So now 8x equals 32. And 32 is a multiple of 8. So I'm going to get a whole value on this. X equals 4. So I end up with 4, 1. And this one will fit on the graph, okay? So I'm going to go back out. I'm going to put that ordered pair on the graph. 4, 1, which is right here. And that's actually good enough to find the rest of the points, because even though the y-intercept does not fit on the graph, the slope does. And from that ordered pair 4, 1 that I just put on there, I can go down 2, there's my down 2, and then to the right 1, which gives me this next ordered pair. In fact, since I'm doing this by hand, I'll kind of go backwards to left 1 up 2. So that's this point, and then left 1 up 2. Boom. There it is. So now I can connect these points. And since this is, remember, this is still an inequality. So now that I've got the graph, or the points graphed, now I need to remember what type of line I'm graphing. And since this one is equal to the 36, it means that I should have a solid line right here. I think I can do a little better than that. Something like this, okay? So I kind of missed that purple point right there. Just make it bigger. So it is a solid line, and the last thing we got to do on this is we just got to find a value to test. Okay, so I'm going to test 0, 0, which is the origin, because it's always a very easy ordered pair to test. Test 0, 0, but I'm testing it in the original, not the equation anymore, because I'm looking for the inequality. I am testing this in the inequality. So that was 8x plus 4y less than or equal to 36. Let's see what happens. So I'm going to replace the x and the y value here with 0, and then we'll see if this gives us a true statement. So not much to calculate there. That's 0, 0. 0 is less than or equal to 36. That is true. I guess I forgot my question mark there, didn't I? So since that's true, then I can shade everything to the left, or everything on the same side of the line as this ordered pair right here. So the origin. So yeah, let's go ahead and shade this in. It doesn't have to be super pretty or super awesome, you know, something like this. Of course, the computer will do that for you on Canvas, but I can't do that. I'm doing it by hand, so this is good. All right, so this now is just an equation. So we just need the line on this one. And so all I'm going to do is I'm going to take this equation and manipulate it for y. Okay, so I'm solving this for y just like we did in 110, which means I want to isolate my y's first of all. Okay, so that means that I would want to get rid of this 12x. So I'm going to show it as minus 12x. And I think I've seen this, or I've shown this before, where I'm offsetting the 10 and the negative 12x because they are not like terms. But when I rewrite this, I'm going to put the x term first so that it resembles slope-intercept form. So that's a negative 12x plus 10 equals now negative 2y. We just dropped both of these, by the way. And then the 12x is zeroed out right here. Last thing we got to do is divide all the terms by the coefficient of y, which is negative 2. Now, this is going to change things just a little bit for us, but it will finalize things into slope-intercept form. So we end up with y equals negative 12 divided by negative 2 is 6. That's positive. And then the y-intercept plus 10 over 2, that's going to be plus 5. Okay? So what do we got on this one in order to graph our line? The first thing I would notice here, and you may have noticed the slope first, but I'm seeing the y-intercept at 0.5, which I can put on the graph. And then the slope, which is showing as 6 right now, but I'm going to make it 6 over 1 so that I can see the rise and the run. The rise up 6, the run to the right 1. Okay, so up 6 to the right 1 from where? That's where that y-intercept comes in. Now you'll notice here, I can't go up 5 and then, or up 6 to the right 1, so I'm going to have to reverse those. Okay, and what this essentially does is it makes it a negative 6 over negative 1, which changes the direction for us so that it, just so I can put on the graph. So it's going to be down 6 because the negative is down for rise, and then the run being negative would be to the left. Now it's going to give me the same stair step, but down 6 to the right, to the left one rather, would be this point, and then I can't even fit the next point on there. So I guess I'll use some technology for this. If I can get it to work. That's okay. I've done worse. So something like this, that would be the line for this graph for the equation. Boom. So on this one, this is there's a couple of ordered pairs on this. Madison rides her bike 9 hours, 22 miles. So this is an ordered pair right off the bat. 9 hours, 22 miles. How do I know that the 9 is the x instead of the 22? Because it's time. And it's in hours, so automatically that's the time right there. And then the next ordered pair, 11 hours for 31 miles away from her house, okay? Now, we could also figure out how far away she is from her house in the beginning, but that's not what it's asking. We just want the rate of change, which means that we're looking at the slope formula. So I say the first point, I'll say that the purple pair is x1, y1, and the x value is 9, so that's in the denominator, and then the y value is 22, that's in the numerator. Then the next ordered pair, x, we'll say x2, y2. So the x value is 11, that's in the denominator. The y value is 31, that's the numerator right there. So you can plug this directly into the calculator. I guess, I don't know. We'll do it piecewise. Negative 9 over negative 2, which would just simplify into 9 over 2. Boom. So they've given us the equation. We don't need the new equations. All we need is the slope for the equations. Now, the thing we need to remember here is that parallel lines have the same slope. That should say perpendicular. Right there, typing's hard for me, my bad. Yeah, the perpendicular line there, okay? So, parallel lines have the same slope. Perpendicular is opposite and reciprocal slope. So the first thing we need to do on this one is just actually figure out the slope, okay? And then we can find their corresponding slopes of parallel and perpendicular lines. So I'm gonna just manipulate this into slope-intercept form, although you're welcome to do it in a different way if you have it. So I'd say first thing for me, I'm gonna just, I need to get rid of the x's actually, so I'd subtract 7 x's here. That's gonna zero that out. I'll drop my negative 7y, which now equals, just keeping this in slope-intercept form, negative 7x and minus 42. Remember, you can't combine those because they're not like terms. And then divide all the terms by the coefficient of y, which is negative 7. And even though we'll have the y-intercept for this equation, we don't really need it. So negative 7 divided by negative 7, that's a 1. You can make that a phantom 1 if you'd like, but I want to see that because I want to know what the slope is. And then, yeah, you'd have the plus 6, which isn't important right now because we just want the slopes. So the parallel line, its slope would be 1 because it has the same slope, just 1, okay? Now, if you look at 1 for the perpendicular slope, okay, so that's, we see 1. You can also write it as 1 over 1. Now, just know if you flip this to reciprocate it, it's still going to be 1 over 1, right? It's just, remember, for a perpendicular line, we want the opposite. So you could say negative 1 over 1, but to make it simplified, it'd be negative 1. All right, to write this in slope-intercept form, remember, slope-intercept form is y equals mx plus b. So, really all we're doing is manipulating this equation for y. And again, this goes back to 110, right? So, on this one, would say, look at your equation here, and we don't want the 7x with our y's, all negative 12 of them. So that means I'd have to zero this out with the principle of equality of subtraction. So I'd have to subtract 7x from both sides. Like this. So that will zero this out, and I'll drop my negative 12y, which now equals, I'll do the x term first just to keep it in slope-intercept form style, and is minus 8 as well. Next thing I would want to do is I want to make that coefficient of y just a phantom 1. So I'd have to divide all the terms by negative 12 here. And one of these fractions will be simplifiable. But then what do I get? Well, that'd give me, oh, dang it. Y equals negative 7 over 12. Yeah, it's just going to be 7 over 12. X, and then negative 8 divided by negative 12 should simplify into positive 2/3 on that. And so, see, now it is in this format. We see the slope, we see the y-intercept, and that'll do it on this one. So, slope from 2 points, yeah, this is where we go back to the slope formula. And, you know, I'll write it out this time. Remember, it's a x1 and a y1 minus the x2, y2 business, like this one. And so as long as you can identify this, these are ordered pairs up and down from each other, okay? Just don't get those mixed up. So, for example, the 5 I'll say is my x1, the 14 is y1. And then the negative 2, negative 9, that's my x2, y2 values. So let's go ahead and replace these as we have them and try to color code these. So I see the x value in the denominator. What the crap? There we go. And it is 5 in green. And of course, it's always in the denominator, the x's. And then the corresponding y value for it is negative 14. So that's my numerator. And then I go and replace the orange values with the ordered pair there, the corresponding values. The x value first is negative 2. And then its corresponding y value is negative 9. So let's go and place that in there. Now, some of you would say, look, use keep, change, put a couple addition marks in there. You don't have to with the calculators we have because the minus button and the negative button are different. So you could just type this in as is if you wanted to. Of course, you can calculate them. What I was talking about is a double negative makes a plus, okay? I know before I kind of showed it as just kind of a big plus sign like this, which is fine if you do it that way, okay? So in the numerator, negative 14 plus 9 would be negative 5. And then in the denominator, 5 plus 2 would be 7. Now, if this could be simplified, we would, but my recommendation and plea to you is just use the calculator, please, because it will do that very quickly and efficiently for you, and it will also simplify it if it can be. All right, I really like graphing these types of equations. I think it's better to see it in a table like this. Okay, so remember, any value of x needs to make this a true statement, and the only value of x that I can see that would make this true is -3, right? So I can go through and just run -3s all through my x's, and then I just need to choose any other y values that'll work. You could say -3 to match, you could say 0, you could say 15 if you'd like, I guess 9, 4, whatever, it doesn't really matter. I know not all those fit on the graph, but that's not important because in order to graph this, it's just important to understand that x has to be -3 to make the original equation true. Your y values don't matter. So -3 would be right here, -3, 0 here, and I can't put -3, 15 or -3, 9 on there, but -3, 4, that'll fit. And we see then that the graph here is just a straight up and down line. Hopefully your line's a little bit straighter than mine, but that'll still work. All right, so on this one, the nice thing about this is it's already in slope-intercept form. It's just it's got an f of x instead of y. If you feel better about replacing that with a y, go and do it, okay? But the nice thing is that it gives us the slope as the coefficient of x because it's in slope-intercept form. So the slope here is 3/2, which again, for us, since both are positive, the 3 being positive, that's rise, so it'd be up 3, and the 2 being positive, that's run, so that would be to the right 2. Well, up 3 to the right 2 from where? That's where we need this y-intercept here. You can just say b if you'd like, but I'm going to say y-intercept. That's 0, 2. So it's up 3 to the right 2 from this y-intercept at 0, 2, which is right there, okay? So from here, I can go up 3 to the right 2, which I will do, up 3, and then to the right 2. There we go, which would give me the next point on this graph, okay? And really, that's all I need to see because I can, we all know that on Canvas, you can just connect those and it'd be done. I like to copy the stair steps when I'm doing this by hand, so left 2, down 3, which would give me this next point, and I can see I can even fit one more, left 2, down 3, boom, like this, okay? And then after that, well, just connect the points, see if we can do this, that's okay, that'll work. All right, find the x and y-intercepts of the equation. Of course, you could change this into slope-intercept form if you wanted to find the y-intercept. But you could just take the equation here, -9x plus 3y equals -54. And I guess over here on the left, I'll do the x-intercept. Now remember the unique thing about x-intercepts, no matter what x-intercept it is, the y value is 0. So I'm just replacing the y with 0. And then I'll solve for the corresponding x value. But I can put the y value even in the ordered pair right now. Okay, so that will zero out this term, and I'm just left with -9x equals -54. That's not too bad. Just divide both sides by -9. Looks like we get x equals 6 on this one. So 6, 0 would be the x-intercept. That's good. But then I need the y-intercept as well. And again, the unique thing about the y-intercept is that the x value is always 0. So let's go back to the equation again. -9x plus 3y equals -54. But now I'm going to replace the x value with 0 and then solve for its corresponding y value. So that zeroes out, so I just got 3y equals -54. Divide both sides by 3. Y equals, it's going to be negative 1, 24, 18, -18. And that represents my y-intercept. And that's it. All right, so f of -2 on this one. Let's make this a little bit bigger for us. And all we're going to do is replace the x with, well, -2. So there's a -2, and then this x over here replaced with -2. We're pretty much just evaluating that at this point, which means that you got to start with your absolute values because we treat them like parentheses first, okay? So that'd be 5 times -2 is -10, and then we will subtract this 8, which would give us the absolute value of -18, which, by the way, is just 18. So everything on the outside, we didn't touch anything on the outside. So that's a 6 plus 4, and then that, we'll put that 18 in parentheses. Please on these problems, especially on the quiz or an exam, don't do 6 plus 4 first, and don't distribute your 4 because of the order of operation stuff, okay? You gotta do the parentheses first. But now it's still order of operation, so it'd do 4 times 18, 40, 72, looks like. So that'd be 6 plus 72, which should finally be, when we add these, 78. So that means f of negative 2 equals 78. Do keep in mind that you can't put absolute values into these calculators. I think that there are other calculators that do, but not this one. All right, so for this one, we got the function, and that's great. So right here where it says f of 0, I'm just gonna write this out. F of 0 equals x squared minus 8x plus 21. But you'll notice that the x value now has been replaced with 0. So I'm gonna go to all my x values, both of them here, and then replace those with 0, okay? Now you could put 0 to the power of 2 in the calculator, which would just give you 0. 8 times 0 then is 0. 0 minus 0 plus 21. Yeah, that's just gonna be 21 right there. And that's also known as the y-intercept because the x value was 0 on this one. So even though this function would not give you a straight line, that's okay. The point here is that that you can still have a y-intercept even with curvy type lines. Now I'm going to do the same thing with f of negative 2. So again, it should be equal to x to the power of 2 minus 8x plus 21. But now it gives me this current x value, which is negative 2. Now you got to be careful on this, especially if you're going to put this in the calculator with the negative base here, especially with the power of 2. You need the parentheses. If you do not put the parentheses around here, even when you put it in the calculator, it's going to give you the wrong answer. And here's why. The way that I have this written right here with negative 2 to the power of 2 in parentheses, that would be negative 2 times negative 2, which is correct. That's going to give me a positive 4 right there. Okay, now if I did this wrong, if I did not use parentheses and I did negative 2 to the power of 2 like this, the calculator would interpret this as negative 2 times 2. See the difference? This is going to come out as negative 4 right here. So please don't do that. Otherwise, you're going to get those wrong, not only on the homework, but tests as well. 8 times negative 2 is negative 16. So minus that negative 16 plus 21. I'm doing it by hand, although you don't have to. In the end, it looks like 4 plus 16 is 20, plus the 21 is 41. So f of negative 2 equals 41 right here. So again, these are ordered pairs, by the way. This would have been 0, 21. And then this one right here is a negative 2, 41, all of which you could put on a graph if, you had a graph that's big enough and wanted to. All right, for this one, we're just trying to determine if this is a function, right? So remember, the best way to tell is to first analyze all of your x values. Okay, so I got 51, 43, 37, and 28. I don't see any repeats right there. So since there are no repeated x values, this is automatically a function. Okay, and again, if they had repeated, you'd have to check those y values. So notice that I haven't even looked at the y values yet. Here I see that they're matching now. This is where the tricky part happens. A lot of students say, well, the y values are matching, so it's not a function. No, the y values don't have any factor on if it's a function if the x values don't repeat. If they do repeat, then that's when you have to check your y values. No x values repeat, so this one is automatically a function. All right, setting up ordered pairs. Now this one right here is showing as 7/2 2, which 7/2, by the way, is about 3.5 right there. So I'm just going to go 3.5 on my x value, about right there, and then 2 up. So, something like this. So we'll call that point A, okay? So I can label it. And then 5/4 we'll say is B. So that's 5/4. The x, 4 for the y would be right here. So that's B. And then see, that's negative 4 for the x, so that's here. And then 0. Oh, so that's not up or down. It's just right there. And then D, negative 3. So I go to negative 3. I go down 3. Boom, there's my point D right there. Okay, cleaning this up. And there's my 4 points on this graph.